Okay. I'm going to record myself watching the keynote here. And I have no idea how I'm going to edit this video, so I might just leave it normal. Those are just all fake people. Yeah, I'm in VR. We're in VR. We're watching the Intel keynote. Look at this shit. It's crazy. Yeah, so that's neat. I just hit random. I don't like any of these people. I don't like what it's doing to me. So, yeah, if things get bad, obviously, I could just do that and miss the screen. Let me see. Let me try that again. I swear I could do better. Does it ever? Okay, here. Oh, okay. Let's try. Down there? I don't feel like I got closer. I guess it's a big screen, you know? Maybe I'll do a smaller one. Yes! Okay. Will that clean itself, please? Thank you. Okay. Yeah. That's pretty neat. I have no idea what the microphone quality is like at all. Yeah. Got 13 minutes to dick around, so... You gonna let me have any, or what are you planning on here with this shit? Can I have some, please? Oh, it's all ephemeral, isn't it? This is bullshit. I can't get it because I'm sitting down. Okay. What's that do? Oh yeah, you could have your own little monitor. That's stupid. Where else can we go? Look at the woods. A balcony? Let's just look at everything. Gotta kill time. That's kinda neat. A big Intel in the sky here. I would be streaming this right now, but I'd rather record this than have to deal with a stream at the same time, because I don't have anything set up to be like, you know, what is it? Just like, I don't know how to pick up the thing. I forget. But you know, I can't like look like, oh, here's the chat. Here's what the chat's saying. The chat's saying things. Hey, fingers work. Thank you. You know, there's the chat. I'm looking at my wrist here. You know, that's where I want the chat to be. I just want to be able to go chat, but that's not a thing. It feels weird to rest my. Anyway, yeah, I would be streaming this, but I'm not. That's all I gotta say about that. So we're just gonna do some things. Oh, now that works. Ooh. Okay. Hey, what happened to the part in the side? How did I make that go away? What did I do? Whee! Oh, I want to like toss the menu around. Yeah, I don't know how that disappeared. What's the woods look like? Huh. Let's get up there. I'll be right here. I can't tell if that... I'm looking at the illumination from everything, and I can't tell if it matches what's on the screen or not. Because if it does, that's cool. I don't know. Maybe I'm simple. What else I got? Oh, that's pretty chill. Jesus Christ. Yeah, you know, that's an apartment. This is where normal people live, that's for sure. I bet. Oh, and there's the balcony, right? Isn't that the balcony from before? Except there was... Can I have my fingers doing things, please? Yeah. Except there was, you know, a thing, a big screen right here, but now it's not. I didn't mean to do that. This game has different motion controls than a couple of the other ones. It's like press the thumb. I don't know. And I wish these weren't always hands. I don't know. I don't know if that's just me. I'd always want to see my controllers here so I could see my controllers. 8 minutes. Okay. Modern seminar. Yeah, that's kind of what I want to see all the time, please. Who's this asshole? Okay, I'm facing forward, like this right here. That's my monitor. So let's go this way. Now let's turn. So I could do this. That's fun. That's always fun. Yes. Oh no. Excuse me. Don't look at me. I'm rude. She's really into it. Good for her. She's an AI. She doesn't exist. Retro cinema. Bleh. I didn't even look up at those before. Okay. God, I'm not looking at all these. Let's go to Mars, fuck it. Yeah, sign me up for that, bro. That's fine. Yeah. But, oh, there are seats here. There's seats on Mars. Sure. I like being higher. Yeah, look at that banding. That's gross. So what do you think Intel's going to talk about? I don't know. Probably stuff. Stuff and things, you know. That's pretty cool. That's weird. I'm not digging that down there. I'm not digging that at all down there. It's like a big hole. I don't know what that's for. Yeah, we're not going to look at him anymore. Okay, yeah, that's some groovin' tunes. The Void. You know, if you're boring, you might like The Void. Let's go to space. It's just not my thing. Yeah, let's go to the living room in my living room. I thought I heard some mic bleeding through, unless that was in the audio. I mean, like, maybe someone on set had a mic that was turned on. Yeah, so this is apartment, but in the living room. That's a thing, I guess. So we can't, like, sneak off or anything? This is big screen, by the way. I don't know if I didn't say that. I don't fucking need to say that. South balcony. Bleh. I mean, okay, I could see, I could actually like this. I want to sit right there, though. Which way am I actually facing in real life? Okay. Desk is here. Works for me. Oh, I actually kind of like this because it's night right now. And this is very bright. And, yeah. 420. Yeah, cool. Cool beans. Let's get that mouse off the screen. Mouse off the screen. This is me using a mouse. Hi. Okay, what would be really cool, and I don't think there is one, because this just made me think of it. It's like, how come I can't be in my computer room right now? Like, having a VR environment that's literally right in front of a computer and you're watching it on the computer, to me, I like that. There's something about it. What's that Lux Theater? Looks kind of neat. Oh, dude. Dude, I actually kind of dig this. Okay, yeah. Yeah, you could tell. That reflected light is definitely from the screen. Yeah. Okay, that's pretty dope. That means it must be emissive? It's somehow turning... Okay, how do you think they do that? An emissive texture, or like an additive... Like they're basically taking the screen's capture screen buffer and then having it projected this way onto the environment. That could be it. Yeah. Oh boy. Cool. Well, I'm gonna put down one of my hands because I want to vape. So he's gonna hang out right here. No, he's gonna hang out my lap. He's gonna be touching me. That's inappropriate. And can I put like a motion sensor on my vape so I could see it in real life? Because I'm holding it in my hand right now, in this hand. Being able to see vape smoke, that would be a feature. I would like that. Vape life. Dude, that's dope music. I don't know. I have really weird taste in music. I like a lot of the kind of like loungy music from like the Wii U sports game. Like the bowling music. That's good stuff. You should go listen to that. I could listen to that on this, can't I? I got YouTube VR, and we're gonna listen to that. Hey there, that's inappropriate. You, good hand. Give him a hand. When's GB gonna take the stage? Come on, I need to see Gregory Bryant. Can I put down my e-cig? Thank you. What else we got? Cool. What can I do with this? That's kind of neat. No, I can't custom color. Yay. Yay. Bye. Oh. Oh. I don't know how I feel about that. What's it doing? Oh, what's it doing? Do it. Wait. Oh. Can you hang out in this guy? Oh, I'm on a cup holder. I'm sitting on a cup holder. We're gonna hold that right there. Ooh, ooh, that's a trip. So you gonna start? Wait, I want to give a thumbs up. Thumbs up. Let's get the mouse off the screen. Some music going on in the background. By the way, I love the headphone things on the whatever it's called, the Index. It's good. They sound like they're coming from everywhere, all the sounds. That's always cool. So what are you seeing? I think I have it set to right eye. So let me see what you're seeing by closing an eye. Yeah, that should be good. With some blasphemy, though. Right now, this recording is powered by a 3950X and a 2080 Ti. So, yeah. Let's see some of them. Oh,
Human intelligence. It's never been defined as just one thing. So why limit the vast possibilities of digital intelligence to a single category?
Yeah, sure.
Like its counterpart in the physical world, computing-enabled intelligence isn't just one thing.
Mobile
It's a
eye.
collection of ever-evolving capabilities. Capabilities that combine to improve our readiness to adapt and change, to recognize and solve problems, to benefit and learn from experience, and to acquire and apply new knowledge. All of which means digital intelligence isn't so much like a new kind of light bulb as it is a new kind of electricity.
Oh,
At
electricity.
Intel,
I like that
we're
stuff.
leveraging the
You know,
power of digital
TDP. That's my
intelligence
thing.
to introduce generation after generation of new technologies that improve the world for individuals, businesses, and society as a whole. After all, the digital revolution isn't just about new devices and algorithms. It's about leveraging technology-based intelligence in all its
Qubits.
forms across the entire spectrum of computing,
AMD don't get that.
from the cloud to the network to the edge.
I'm edging
To
right
you.
now.
That's innovation through intelligence.
Please welcome Chief Executive Officer, Intel, Bob Swan.
Ooh, Bob Swan. Golden teeth. Beautiful smile. Love him.
Wow. Happy New Year. Good afternoon. This is the part where you participate. Happy New Year. Good afternoon. Welcome. And thank you very much for spending some time with us today.
Sorry.
My name is Bob Swan. It's a
That was
pleasure
cringeworthy.
to be here. I'm going to do a little bit of an introduction, a little bit of stage setting before I invite Naveen Shenoy and Gregory Bryant up to talk about how
GB.
we're deploying some of the innovations and technologies with our ecosystem partners. What we're going to hear from us is what we characterize innovation through intelligence, and what we believe Intel's role in conjunction with our ecosystem partners, which is to power generation after generation of new technologies that change the world and enrich the lives of every human on Earth. So our ambitions are rather big.
Lofty.
But
I
we've
would have
been
said
at this
lofty.
for a while. Since our founding 51 years ago, Intel, with its ecosystem partners, has been leading this computer revolution. And over that time frame, we've gone from a mainframe to a PC, to a mobile device, to a server, to the cloud, to a world today that increasingly everything looks more and more and acts more and more like a computer. And that's happened through relentless innovation. Relentless innovation to bring new things to life by developing Moore's Law and the scaling abilities and new architectures that allow us to introduce new technologies never thought to be possible. Let me put it into context a little bit, just in terms of the devices that exist today. In 2019, there were 38 billion devices connected to the network.
Let me check something real quick.
And that's expected to grow to 56 billion
this would suck.
devices by 2025. So a lot of devices and a lot of growth in those devices over time. Roughly 75% of those devices will be Internet of Things. So think about 56 billion devices. That's roughly 7 per human on the planet of devices being carried around or being leveraged to enrich the experiences that we have. To put it into context, 7 devices per individual, billions of devices creating things. And those things that are being created is called data.
Okay, cool.
Over
That's
that
all I wanted to
same
check.
time frame,
Sorry.
Our expectations is there'll be 175 zettabytes, growing at roughly 25% year on year between now and 2025. 175
Because wouldn't it have sucked if I did all this and I didn't have the audio?
2025 being created. Now, I'm sure a lot of you over the holidays spent a little time consuming HD content. Anybody in the room consume some HD content?
Yeah, over 500 gigabytes.
175 zettabytes of data created is equal to
If it made some.
6.5 billion years of HD content.
Well,
so
4K.
A lot of data is being created by these billions and billions of connected devices. And over this time frame, roughly 50% of that data will be created by devices at the edge.
Sorry. Squeezing myself down there.
Smart devices, wearables, smart industrial factories, technology being deployed to make retail shopping experiences greater, and connected cars. 50% of the data that will be created will be from these billions of connected, intelligent devices at the edge. And only 1% of that data today is being processed by artificial intelligent models. We are only just getting started in terms of the amount of data that's being created and leveraged to create new and better experiences around the globe. All this data that's being created, something needs to be done with it. And the implications for silicon and for the technology that we develop is the data, everything needs to be processed. It needs to be processed to make the data more relevant, more useful. And more data needs to be stored. And it can't be stored for retrieval over time, but readily accessible immediately. And third, more and more that data needs to move faster and faster within and between networks so that it can be processed again. And this is a world where we have been playing for 51 years. Process everything with advancements in compute, store and retrieve things faster and faster, and move data around networks more and more. And if you take the incredible growth of data and the need to process, store, and move faster, those are being enabled by what we characterize as 3 emerging technologies that we believe will have an incredible impact on the technology of today and the technology platform for years to come. And those 3 technologies are 5G,
Meh.
artificial intelligence,
Okay.
and intelligent edge, or intelligent devices at the edge. And these technologies are not standalone technologies. They're actually reinforcing. For example, 5G increasingly is a part and required because of the billions and billions of connected devices at the edge. And AI is making 5G and this convergence of compute to communications to be more and more relevant. Secondly, these billions of intelligent devices at the edge need to be able to have more and more compute closer to them.
Mm-hmm.
So not only are 5G is an enabling intelligent devices, but intelligent devices are putting challenges on developing the technologies for AI and for 5G. So they're not independent technology functions. On the contrary, they're self-reinforcing for each other. And the challenge and our role is to fuel silicon technology and software at the core at each and every one of these key technologies. So what we've been focused on is how do we embed intelligence into everything that we make to enrich the experiences for consumers and the capabilities of our enterprise clients and ecosystem partners. We're simply embedding intelligence across everything that we do. And we're investing in technologies across all 3 of 5G, AI, and intelligent edge organically and acquisitively to ensure that we can meet the needs and the demands of our global ecosystem partners and consumers around the world. And we feel like we're only just getting started. And our capabilities have been enhanced by acquisitions we made along the way. Nirvana, or neural network processing, a couple years ago, the acquisition of Mobileye and computer vision, an acquisition of Movidius to add consumer vision technologies at the edge, and most recently an acquisition of Habana. We are making investments across all 3 of these technology inflections because the expectations that we have for us
What are you doing with your
to
fingers?
make the world a better place and to enrich the lives of every consumer on the earth. I want to give you just a couple of examples before I hand it off to Naveen and GB that underscore what we characterize as world-changing, but even life-saving technologies being deployed at the edge. So I want to kind of start with transportation and where compute-based intelligence can literally be a matter of
I know you're
life
trying to
or
do
death,
this thing,
or bringing technology
it's kind of hard
to
when you're holding the
society
thing,
for good.
because, you know, that's like converging,
Acquired
mixing.
Mobileye, back in 2017, and the intent was to lead a transportation revolution with the goal of saving lives.
Yep.
And we've been using a unique approach combining what we call our RSS model, which is a publicly available framework that standardizes the decision-making process of a robo-car. And it's been made publicly available so the universe can adopt the same kind of standards over time. And that RSS technology, coupled with true redundancy, in which we build robocars with independent sensing systems, cameras, radar, and LiDAR technology, is what we've been able to do and build. And I want to just show you a clip of what we believe is the power of the approach of RSS and redundancies in bringing autonomous driving to life. Now you'll see, hopefully you can see a video behind me. And this is our
Yep.
mobile car navigating a challenging intersection.
Oh shit,
Jerusalem.
dude. Oh,
Has anybody
dude.
driven in Jerusalem or been in a car in Jerusalem? I've had a chance to be in a car in Jerusalem. And fortunately, I was not driving because it is not safe. But what you can see here,
Ooh.
this is a Mobileye car pulling
Ooh.
up to an intersection. And you see it coming in, sensing, RSS, sensing what's going on around it, using cameras and technology to make a determination of when do I move out into this street and when is it safe
So give me the details.
for
What's it
me
got?
to move forward. Now again, I
LiDAR,
had a chance to do
cameras.
this, and they told me I was going to get in this car, and I said, not on your life am I getting in this car. But we went through the highways of Jerusalem, the city streets of Jerusalem, and all the chaos around it. And I was much more comfortable letting Intel Mobileye Technologies move this car forward than I would have ever been sitting behind the wheels of a car. So it's been pretty impressive what the team has been able to do. And we're not stopping there. We're building an entire stack to become a mobility service provider. And our goal is simple. To bring innovative technologies and intelligence to revolutionize transportation by deploying the power of compute and of AI. That's one example. The next example I want to share with you is applying intelligence to disaster relief. Intel has partnered with the American Red Cross, essentially to improve disaster relief around the globe. Many developing countries today do not have complete digital maps, things that we increasingly take for granted.
Mm-hmm.
And therefore, it's extremely hard for rescue workers to use information to be able to get to the danger zones. It makes the relief work extremely difficult without having these maps. Well, we've deployed our second-gen Xeon scalable processors, combined with intelligence of Intel employees who volunteered over 1,000 hours, were used to improve the relief efforts by the heroes on the ground. I want to share a video with you about how.
After Hurricane Maria hit Puerto Rico, I was on the ground in 24 hours as part of the first group of Red Crossers that went down to the ground. And one of the very first things that we discovered was that everyone was trying to navigate using their phones.
As somebody who's been on the ground using mapping software, it's extremely important to have accurate maps. We've run into situations where roads have been destroyed, and what could have been a 20-minute drive for one of our drivers was a 5-hour drive, trying to get food to communities where there isn't food. Those are some big challenges for us.
So the reality is, we're blessed in the United States, we're blessed in Europe, we have a map. I've been to villages in Africa and in Asia where we are literally for the first time digitizing that map. A couple years ago, we got together with Intel and they were curious about how they could help us, saying, hey, I think a computer can do this better.
We set out to build up what we would call a computer vision model that can be used to take in as an input a satellite image and then spit out on the backside the location of a bridge if there was a bridge in the image. We started off with Uganda. When we look at the amount of time it takes an individual mapper to hand draw all the roads, waterways, and bridges in that tile, that time period is roughly around 13 minutes. However, if we run that tile through our model that's already been trained, we can generate predictions in seconds per tile. So for us to scan the entirety of southern Uganda and generate those predictions, we did that in just a couple hours.
Technology and AI in particular is making things just that little bit faster. Disasters are changing. They're getting more complex, they're getting bigger, they're getting faster. They're getting harder to respond to. And that's why we need more tech tools to help us out.
Oh, that's cool.
This is just another example of how we can use technologies to have a real impact on the world. Today, the challenges we face in a global society are just getting more and more complex. They're getting bigger, they're getting tougher and harder to solve. it's just worth pausing for a moment to recognize the efforts when we're talking about rescue missions, the efforts of the first responders in Australia and the role that they're playing to try to eradicate the situation in Australia that's having a real impact. So I think it'd be remiss if we didn't just pause to recognize the role of the first responders, to thank them and send our prayers and well wishes for their safety. At Intel, we recognize the responsibility that we have for groundbreaking technology and to deploy technology tools, and to do so in a way that enriches the lives of every person on Earth. That's our ambitions. That's what we've been focused on for the first 51 years of the company's in existence, and our expectations we have of ourselves as we deploy technologies going forward. So now Naveen and GB are going to come and tell you more about how we're innovating through intelligence to positively impact society, to positively impact business, and to positively impact people. So join me, give a round of applause for Naveen to come out. Good pace. Good pace.
Good to see you. Good to see you. Happy New Year.
Happy New Year. Hey.
Oh, we got it. Okay, yeah. Happy New Year. Great to see you. Let me just add my welcome to CES. As Bob mentioned, I want to talk a little bit about the economy that we live in today, the data economy, and the way in which it's transforming businesses in profound ways. One of the behind-the-scenes forces that makes the data economy happen is, of course, the data center. And Intel technology has been at the heart of the data center for decades. Over the last few years, we've been investing to expand from the central data center to the network, to the edge, to every person on the planet, across every industry imaginable. And I'll take you through just a few examples of that today. And I wanted to start in the first example in intelligence transforming the way we experience entertainment. Just 10 years or so ago, most of us had cable or satellite TV, and many of us would head on a Friday night to the local video store and rent a movie. Fast forward to today, and I don't know about you, over the holidays, we could binge watch just about anything we wanted, any number of TV shows, movies, and user-generated content through streaming services. In fact, the creation, consumption, and transmission of video represents about 80% of internet traffic around the world. And as more people cut the cord and 4K and 8K services combined with 5G with higher bandwidth and lower latency, we expect that video will continue to be the killer app of the internet for a long time to come. Now, one of the most recognizable names in video content delivery, of course, is Netflix. Last year, Intel and Netflix announced a collaboration for our next generation open source encoding and decoding technology optimized for second generation Xeon scalable processors.
I've been trying to use AV1 codec.
To ensure that
it is
quality and the cost
a
of
mess.
these services continues to improve. To share more on
I would
the
love to
partnership that we
test
have
it with
Netflix,
one of those
I'd like to welcome
Xeon
Netflix's
scalables, though.
Director of Encoding Technologies and one of Forbes' top 50 women in technology, Ann Aaron, to the stage. Welcome, Ann.
Hi.
So technology innovation has been helping Netflix obviously transform for many years, and you've been busy expanding your
He's really natural in front of the
all
camera.
corners of the world. How have you
On
been
the stage.
at Netflix able to navigate through these changes and still remain successful?
Well, at Netflix, we only do one thing, entertainment. And we aim to do it really well. We live and breathe TV and films. We want everyone to enjoy them too, whether it's an easy escape or something that provokes debate. We're also obsessed with improving the consumer experience, whether that's no ads, complete control over when you watch and how you watch, better discovery, more enhanced sound and picture quality,
Picture quality, yeah.
or even pioneering new formats like interactive TV. And today we're just scratching the surface of what's possible. We know that if we stay focused on consumers, we're confident that more people in more countries will choose Netflix for their entertainment.
So what role do the technologies that we announced together last year, the video codecs, play in your ability to continue to enhance the consumer experience, Ann?
Yeah, Naveen, video codecs are a crucial innovation that help deliver a better experience for Netflix members. It's important now and also into the future because it enables better streaming quality at lower bit rates. That means we can send smaller files without compromising video quality. With better compression technology, we can offer more efficient services with existing infrastructure.
That's...
And so where is the industry headed then with regard to more efficient?
Okay, I guess maybe that's
Industry collaboration on the royalty-free codec AV1 has delivered up to 60% better compression
if that's
efficiency
I have
over the
arguments
legacy
about that.
codec AVC, and is poised for notable adoption starting this year.
Now, the collaboration we announced, can you speak a little bit to the business transformation that you expect to see? Because this one was about the sort of next generation of AV1. We call it SVT AV1, or Scalable Video Technology AV1. Can you talk more about what you see there?
That's right. When we were looking at the AV1 ecosystem, we realized that there was a need for a clean reference encoder that could be used by developers today, as well as could serve as a code base for next generation code.
I know the
research.
FFmpeg one
At
is
Netflix,
crap.
we decided that this was a problem we wanted to lean into. At about the same time, fortunately, Intel started developing its own open source SVT AV1 codec. So we decided to just join forces where we could each dedicate our expertise to different parts of the project. And thanks to our joint efforts, the optimizations on Intel Xeon have yielded significant quality and performance gains, making SVT AV1 ready for commercial deployment. You can expect to see AV1 adoption not only at Netflix, but from many others in 2020, thanks to the collaboration with Intel.
And thank you very much. I look forward to continuing to collaborate.
What about hardware
Thank you.
decoders?
Thank you for being here. Now, when it comes to intelligence transforming businesses, there's perhaps no more profound change happening than in artificial intelligence. We believe that AI hardware will be a massive opportunity for the industry, a $25 billion opportunity by 2024. And at Intel, our strategy has been to provide customers with a heterogeneous set of choices to fit all of their needs at every power level, every performance level, from the edge to the data center. And the breadth of this portfolio approach that
X
we've
to the
taken over
power
last
of
few
E.
years is what enabled us to deliver $3.5 billion in AI revenue in 2019. Last year, I announced here at CES the Intel Neural Network Processor for Inference, an entirely new class of AI chip built specifically to solve our customer inference problems. NNPI is already delivering impressive results here. Versus our competitors, we're seeing up to a 1.6x improvement on natural language processing workloads and up to a 3.7x improvement in overall
Who would your
system-level
competitors be?
performance. We're launching this product later this quarter, and we expect the NNPI to deliver performance per watt leadership in a 75-watt power envelope.
Oh, impressive.
Now, the AI market is obviously adapting and evolving very quickly, and we're investing, as Bob mentioned, to win here. We believe it's going to take multiple technology types to truly solve the complex problems our customers are dealing with. And to that end, last month we announced the acquisition of Habana Labs. Habana offers a programmable AI solution with a common architecture between training and inference. And we're excited about the capabilities that Habana is going to bring to our portfolio. We expect to see and announce exciting news about the Habana product line later this year. While dedicated AI products get a lot of the buzz in the industry, it isn't the only solution. The Intel Xeon Scalable Processor, in many ways, is the intelligence foundation for enterprises around the world. More data center AI runs on Xeon than on any other platform. In fact, Xeon is the only general-purpose processor with AI built in.
Yep.
A few years ago, we infused AI capability into Xeon for both training and inference, starting with AVX512 and our first generation Intel Xeon Scalable processor. Last year, we continued that development and evolved by adding Intel Deep Learning Boost into the second generation Xeon Scalable. And with Deep Learning Boost, we saw an incredible 30x improvement in AI inference processing done on Xeon. And I'm happy to report that in 2019, this workload-specific acceleration has helped make the second generation Xeon Scalable our fastest ramping Xeon in our history. Later this year, with our third generation Xeon Scalable, which is on track, we will be extending DL Boost with new enhancements for AI that will provide up to 60% increase in not just inference performance, but also for training performance.
Cool.
Last year at CES, we gave you an example of how AI on Xeon is being used for new use cases, emerging use cases that are fairly compelling and interesting. And one of the examples we gave you last year was 3D athlete tracking. We announced our intent to bring 3D athlete tracking, or 3DAT, to the Tokyo Olympics this year. As a reminder, 3D athlete tracking, it's a first-of-its-kind computer vision solution that uses AI to enhance the viewing experience with near real-time insight and visualization. 3DAT uses cameras to capture the athletes. It applies algorithms, and then it optimizes that solution using DL Boost to analyze the form, the motion, the biomechanics of the athletes. There's no special suits, there's no special sensors, just the data and the AI. I'm excited today to announce that this technology is going to be used to provide broadcasters the ability to broadcast events like the 100-meter dash and other sprinting events at the 2020 Olympic Games. There's incredible challenges here when you think about the 100-meter dash. You have to separate the athletes from the coaches and the spectators. You have to correctly identify each of the 8 athletes across multiple different camera angles. And that's all before that data is then fed into the skeletal tracking models to extract the body position, the velocity, the relative position of the athlete on the track. And then all of that has to be sent to the broadcasters in under 30 seconds so that they can do the replays immediately after the event. So the second generation Xeon Scalable with DL Boost is what's going to provide the performance necessary to meet those demanding
That'd be
SLAs.
neat. Broadcaster could like step
The
into
intelligence
the race
delivered by
and then
3DAT
pause it.
is also being used to enhance the way the U.S.
It's like a
Olympic athletes
AR kind of
train.
thing.
And instead of me telling you about this, I thought it'd be interesting to hear from a real Olympian. So to tell us about how 3DAT intelligence is transforming the way Olympic athletes are training, I'd like to welcome 2-time Olympic decathlon gold medalist Ashton Eaton. Great to see you, Ashton.
Good to be here.
So the decathlon, your event, 10 events, but I heard your favorite event and the one where you hold the decathlon world record is the long jump.
That's right.
What was that world record?
27 feet, give or take a few grains of
I
sand.
thought it'd be fun to show you guys what 27 feet looks like.
All right.
They got
This
it all
is how
taped
far
out already.
Ashton jumped.
Are you
We're
sure that's
standing-
27?
We're standing 27 feet apart right now. So that's what he was able to do. Doesn't that blow your mind? So Ashton, maybe you could tell the audience about what the training process is.
I could jump that far if I wanted to.
Like yourself.
For sure. Yeah, a typical week, we train Monday through Saturday, and we'd spend about 20 hours doing stuff on the track. We'd spend about 5 hours a week doing stuff in the weight room, and then about 10 hours on recovery. So all told, you're looking at 30, 40 hours a week on performance.
So that kind of sounds like a full-time job.
Definitely felt like it.
And speaking of jobs, you're actually an Intel employee now, isn't that right?
Yeah, that's right.
So what
Why?
are you working on, and why Intel?
Actually, this last summer, Intel invited myself and a bunch of other Olympians out to Olympic Day on campus in California. And that's where I met the 3DAT project team lead. And I asked him what he was working on, and he said, well, we're working on a system that can track and analyze human motion without the need for the athletes to wear sensors. And I was like totally shocked that was even possible. So I just started drilling him with questions, and eventually actually invited me to the lab to see the work. And after the tour, asked if I wanted to help bring it to life. And so I saw it as an opportunity to work with a technology leader on human performance and said absolutely.
That's great. And so I understand the U.S. Olympic team is now using 3DAT to enhance the training process. We have some video from the last training session at the Chula Vista Elite Athlete Training Center. What benefit do you see 3DAT, providing to Olympic athletes?
I think, sport is so fascinating and important because it's about seeking and celebrating human potential. I think through sport, we actually answer the question, or try to answer the question, what is our species capable of? And we try to answer that by improving our performance. The way athletes do that today, well, actually, I think this technology has the capability to take us to the next level. And the reason I think that is because the way athletes get better is they go to a training session, they'll do a dozen or more attempts at an event, and you multiply that by 5 or 6 days a week, by a 40-week training year, and then by probably a 10-year career. You're looking at 30 to 50,000 data points on each event that they're doing. And the way the athletes improve, which is it's amazing how far we've come doing this, is largely by 3 factors. What they felt during the attempt, what the result was, and what the coach saw. I think that 3DAT could be the 4th factor in advancing human performance by bringing precision analysis to human motion. So now when an athlete runs down the runway in the long jump and tries to jump 27 feet, they'll not only know what they felt, what the result was, what the coach saw, but what every single part of their body was doing at every moment in time. And apply that over the tens of thousands of attempts an athlete will do in their career, there's an incredible amount that we're going to learn about how to improve. And once they apply that knowledge, I think the sky's the limit.
That's awesome. Well, this is really exciting stuff. Thanks for being here.
My pleasure.
And we'll see you around campus.
That's right.
Yeah.
Thank you, guys.
So bringing intelligent insight into the way athletes train is just one way intelligence, I think, is transforming sports. Many of us also enjoy watching sports, and if you think about it, the typical sports viewing experience hasn't really changed in the last decade or maybe even in the last 2 decades. And so what I'd like to do now is to share a little bit more about how the intelligent edge, distributed computing are now helping us evolve the way sporting experience is going to be viewed. And to do that, I'd like to welcome Vice President, General Manager of Intel Sports, James Caruana, to the stage.
How
you doing, man?
Good
to see
you? Well, you talked about how the experience of sports hasn't changed over the last couple decades, but we find ourselves at a time that consumer demands have greatly shifted, really evidenced by how fans create, interact, and share content experiences. So think about Snapchat, TikTok, Twitch. These are platforms where fans are becoming their own producer, and they're valuing real-time and interactivity. So here you have fans that are telling us how they want to interact with sports content. And what we hear, the more we talk to them, is that fans are looking to see the game from their own perspective, whether that's the quarterback, the wide receiver, a safety, or a referee.
They already do all that amazing stuff on football fields.
Share their unique insight with their followers. Hell, Naveen, if you could sit on your couch, have a live game on the TV in front of you, be able to pick up a controller and interact with the content like it's a video game, these are the types of experiences that we're working with the sports leagues to create.
So this seems pretty cool. How does it all work?
Well, the baseline here is really volumetric video. It's
the
technology platform that allows fans the capability to lean in and interact, or lean back and get a personalized feed. So how it works, instead of placing cameras at a few strategic locations on a field and cutting from camera to camera to camera, as in traditional production, we place cameras around the circumference of a venue. And with those cameras, we capture the visual information not as a 2-dimensional pixel, but rather as a 3-dimensional voxel. And when you capture the information as a 3-dimensional voxel,
that's cool.
It gives you the capability to see the action, to show the action from any perspective on the field. And this is that underlying capability.
So you've been at this for a few years now, right?
Yeah.
So tell us what progress you've made.
Well, we've made some pretty fantastic progress. Our goal is to be able to achieve high-quality, cloud-based, streaming volumetric video. It's a mouthful. And we started in 2017 with what I'll call a mid-quality on-premise, single-frame solution, and we decided to evolve speed first, quality second, towards our goal. And I'd like to kind of walk us through that process. So in 2017, we could produce a volumetric frame in 3 minutes. And with this volumetric frame, we would create broadcast enhancements like the one you're about to see here from the NBA. You have a traditional 2D feed, you go into a volumetric frame, and from there you fly the virtual camera and see perspectives where there isn't a physical camera. Now, we've been producing these broadcast enhancements. It started out with 3 minutes per frame. In 2018, we sped that up by a factor of 6 to 30 seconds per volumetric frame. And in 2019, we made a big jump, like, as you said, taking advantage of distributed computing, computing at the edge, computing in the cloud, and we sped things up by a factor of 900x. So now we can produce volumetric frames instead of 30 seconds per frame, 30 frames per second. And with that, we've achieved the world's first large-scale, cloud-based streaming volumetric video platform. And it was really a monumental challenge for us because we had to push computing and networking to its edge to be able to process this amount of data. And what I'd like to show now is the output. I think that's what we all want to see, right? And I'd like to show you what now a mid-quality, cloud-based streaming volumetric video platform produces. And on a screen of this size, you'll get some pixelation, so you'll have to excuse us right now with that.
Cool. Let's take a look.
I got to applaud him for taking time to say that phrase perfectly. That's hard.
And what you're seeing here is a virtual camera. There is no physical camera pointing at the field at this location. And this was produced in the cloud, streaming at 30 frames per second.
It's not bad.
The 2D stream came back down to Earth. And in order to do this, we had to process a ton of data.
There's a little bit of...
So the raw cameras produce 67 gigabytes of data per second.
Okay.
And that data gets pre-processed, compressed, sent up to the cloud. Once in the cloud, we spin up hundreds of machines to create the three-dimensional model. And then once we have that model, we can produce any number of streams with just a handful of additional streams like the one that you're seeing right here.
So what happens if we remove the bottlenecks of computing that you have today? What could you do?
Well, I talked a little bit before about some of the use cases that volumetric video can attack. A fan who wants to lean in and interact with content, a fan who wants to lean back and get a personalized experience, or a content creator who's looking to share their own personal perspective to their followers. So what we could do is take our current technology capability and really map it against some of these use cases to be able to illustrate those points.
Neat.
So what you have here is a little GUI that we mocked up, where on the left-hand side you see examples of various streams that a professional or a casual producer could create. And with volumetric video, we can create infinite perspectives, any location, any position on the field. So as an example, we can show what is it like to be the quarterback during the snap. There is no camera on the quarterback. This is entirely created from our 3D model of the game. But let's say you love defense, right? What about seeing things from the safety's perspective? And let's say you want to go up a little bit higher, call it the bird's eye view camera, but again, from the defensive side, a view that you'll traditionally very rarely see. And I hope what you're seeing here is that the promise of volumetric video has in sports. We figured out the speed portion of the puzzle. Now we got to work on the quality portion of the puzzle. And that's where I think we've got to work really, really closely together, because to get from where we are at this mid-quality level to the high-quality level, we need to increase our computing by a factor of 6x. And that will allow us to go from a perspective of HD 20 yards from a player to a perspective of HD 6 yards from a player.
So you need 6 times more computing power.
Can you bring it?
I think we can do that.
All right.
AI upscaling and crap like that.
Appreciate it.
Mix that up in there. Work with NVIDIA.
So that's a quick look at some pretty amazing examples, I think, of how Intel is bringing the advantages of digital intelligence to the world from behind the
Get some DLSS on there.
That's, of course, only one side of the story. To realize the full possibilities, we also have to advance the technologies and experiences on the client. And to do that, let me hand things over to GB.
GB, client. Looking good.
Right. Hey, afternoon, everyone. I think that was just incredible stuff, and I'm excited to be here at CES again this year with all of you, and I want to share our plans to really drive excitement and new experiences in the PC. You know, we see the PC as an intelligent
Couple holiday
platform
pounds.
that
That's
helps
okay.
enable people's greatest contribution. You know, the thing that's unique about
Nice
the
shoe.
PC is it's where people go to focus. It's where they go to achieve more. It's where they go to do the things that matter the most to them. That's what makes it unique. And what makes Intel unique, increasingly, is our ability to innovate and optimize solutions at a platform level. Let's take a look.
Yeah, let's look. Yeah. Okay.
All right. So hey, our mission is to advance the PC experience across the entire industry. And that's why we started on a multi-year journey that we call Project Athena to drive that innovation.
Yep.
And that was really driven off of deep human-level understanding of how people use their devices. And it's more ambitious than anything that we've done in the industry before. And for the first time, we developed a specification with all of our partners, many of whom are here today, to really deliver on the key experiences that people care about the most, so that people know when they get a Project Athena-based device, they can be certain that it's been tuned, tested, and verified to actually deliver on that experience. And like all of our products that are, including Project Athena, we have the widest application compatibility and hardware compatibility to give you the best experience in the industry. So the response has been tremendous, and I'm incredibly proud to be standing here today and tell you that in less than a year, we have already verified 25 new Project Athena unique base devices that I have here on stage with me today.
I have no idea if my new MSI is.
Now, what's even more impressive than just the number is really the breadth of designs from consumer all the way to commercial, and they're really setting a new standard for mobile computing in the industry. Now, for consumers, that means 9+ hours of battery life, but like in real working conditions, actually using the device. Or of course, more than 16 hours of continuous local video playback. It means better responsiveness and performance, right? Helping launch applications faster, less time spent when you're going in between tasks, keeping you in the flow and keeping you focused. It also means fast charging capabilities, getting 4 more hours of battery life in just 30 minutes of charging. And then absolutely no lag time. All of those devices on stage, when you open the lid, will resume from standby in less than 1 second, and many more things. And in the commercial space, in addition to all that, we've got vPro capabilities that enhance security and manageability for professionals and IT professionals all around the world. So with that, I did want to have Chuck and I just to quickly highlight a couple of designs that are new, launched in at CES right here today, and you've got a consumer example.
Yep, so here's the Acer Swift 3. It's thin, it's light, with a screen-to-body ratio of nearly 85%. It's incredibly immersive.
Yeah, it's a great consumer example, and I know you have one commercial example I really love.
Yeah, I love this one. Now, this is the HP Dragonfly Elite. It's also very thin, 360-degree hinge, built-in privacy screen, and also the first laptop that uses plastic recycled from the ocean as part of the construction process. Extremely cool.
Wow, that's really unique. Let's give him a hand. I think that's great. Now, the momentum for Project Athena is continuing in 2020. We now have over 120 companies onboarding, helping us drive all this innovation. And together with our partners, we're committed to doubling down and doubling the number of designs in 2020 to over 50. But our ambitions for Project Athena are even greater. We're going to continue to add partners and experiences, and I'm pleased to announce one today. You know, we've been working with Google now for years, from the very beginning, and we started really working with them to bring the highest performance experience possible to Chromebooks based on Intel Core-based processors in their Chromebooks laptops. Now, what I'm excited here today is to say we have extended our partnership with Google to include Project Athena for the first time, which means you're going to get all the leading security, manageability, ease of use, and nearly 3 million applications in the Google Play Store all together on exciting new Project Athena devices. All right? Yeah? Pretty cool? And further, I have the privilege today, it's not just a partnership, of actually launching the first 2 Project Athena verified Chromebooks on stage with me. And Chuck, you've got them right here, right?
Exactly. So we have the Asus stylus, the Asus Flipbook, the C436, again, incredibly stylish. And also, we have the brand new Galaxy Chromebook from Samsung, also very stylish, 9.9 millimeters thin.
That's right.
4K AMOLED screen. The colors are vivid, the screen is bright, and you get all the benefits that GB just told you with
That's
Athena.
Right. Super immersive, brand new display, great technology. Thanks, Chuck. And that's just the start. You know, you can expect us to drive more designs, more innovation all through the year in 2020. So where do we go from here? Now, you can expect a lot of new innovation from us going forward, but there's 2 areas in particular I just want to highlight today. One is connectivity, and the second is form factor. So in the space of connectivity, you already know that we drive industry-leading integration of Wi-Fi 6 in our PC platforms, and now also LTE-based module solutions. But we're going to go beyond that and extend 5G support into our PCs. Now, in fact, if you weren't watching over the holidays, in November, we announced a new partnership with MediaTek to deliver 5G modems in a module with us, optimized for our PC platforms. And we're making great progress, and we expect those solutions in samples to be out to our customers in Q3 of this year. So we're doing some great work there. Second, in form factor innovation, we came up on this stage at CES last year and then at Computex in the middle of the year, talking about innovation in the form factor and in dual screens in particular. And today, I'm pleased to announce that we have actually released a new Project Athena-based specification for dual screen devices to all of our OEMs. But instead of just talking about the specification, I wanted to do something special and invite somebody out to show some of the innovation, including a product that they're launching here at CES, announcing today, and that's the president of Lenovo's commercial PC division and smart device business. Please join me in welcoming Christian Theismann. Christian, you want to come on out? There he is.
Hey, GB, Happy New Year. How are you?
Good, I'm doing great. It's good to see you. So, what do you have for us today?
Well, first of all, congratulations to all these Athena devices.
Thank you.
It's great. We're also announcing 2 devices basically today. One on the consumer side, our Yoga Slim 7 platform, and on the commercial side, our famous ThinkPad X1 Carbon in the next generation.
No, that's
so
right.
Very excited.
And you guys have been part of Project Athena from the very beginning.
From the very beginning.
Yes. Co-engineering's been great. But I know you have something new and special that you wanted to show today.
Well, about 4 years ago, we chartered a joint project to really come up with a radical PC innovation for a new generation of power users who really want to have an all-day device and using it throughout all day scenarios. And I'm very excited that today is the day where Lenovo and Intel are jointly announcing the world's first foldable PC.
Wow. All right, let's give him a hand. That's great. Thank you. Christian, that's beautiful.
So this is a full performance PC device based on Intel's Core hybrid technology.
That's right.
It's 5G capable. It's a 13.3 OLED device, less than 1 kilo.
Wow.
And it's really built for all-day computing. You can use it really as basically a tablet. You can use it really to compare things.
You're doing this very well, by the way. This is
Thank you.
difficulty.
Yeah, live demos are hard. There you go.
You can also use it as a video conferencing device. where you also have supporting informations on the second screen. So you have a dual screen device in one screen. You can use it with a pen to draw while you still receive information. You have an inboard keyboard, but you also have an external keyboard. And at the end of the
And
day,
yeah, he's just
when you go to
scrolling
bed,
through a picture
you
album,
still
but
have a book.
you know.
Very good.
So
That's fantastic.
we're very excited about this. This is a new category of devices we are launching today.
That's fantastic. Thank you, Christian. Very
Thank
much
you
for joining us.
Thank you.
Thanks for all the great co-engineering work. Absolutely beautiful. And appreciate being able to do the announcement today with us. And hey, and going forward, we're going to continue to drive innovation in the form factor and display. And I've got another example that I wanted to share to you today that we've been working with our partners at Dell to drive even larger size dual screen devices for productivity and creativity. And they've agreed to let us give you a sneak preview of that device on stage here today. So Chuck, you're going to do that?
Absolutely. So as you were saying, our partners in Intel are really working on making sure, Dell, exactly, sorry, making sure these systems are easy to use and also very productive. So this looks like a standard laptop at first blink, but keyboard comes off, goes underneath, and you can see we have now 2 large screens to work with. Now, we have 2 applications here. We got a browser and we got notes. If you want to move those applications around, it's just really a simple move to move them back and forth. I can then launch an application on the second one. And again, if I want to take and spread an application across 2 screens, I can have all that. And even though I start at the top, I can pin it to the bottom. And so you can see, when you're done, one thin device to work with.
Fantastic, fantastic. Thank you, Chuck, very much. Really appreciate that. And thanks to our partners at Dell for letting us show that on stage today. Now, the Lenovo X1 device and the Dell Concept Duet, which is the platform Chuck just showed you, are really showing the promise of advanced usages in the PC. And you can also count on us, just like we did here at CES and at Computex last year, to continue to drive innovation forward. And I've got the privilege of showing you something no one's ever seen before from us, which is our new concept platform, the code name of which is Horseshoe Bend.
Okay.
And this device was specifically based on research that we did that suggested that users wanted an even larger foldable device for enhanced productivity and creativity. And surprise, we've got the corporate vice president of our mobile platforms group, Chris Walker, on stage to join me to show this thing off. So Chris, you want to?
Hey, I'm super excited to be able to share and show the world's first 17-inch foldable OLED PC as we create what's next in the laptop in 2-in-1. Now, as a concept platform, allows us to continue to push boundaries on what's next and solve engineering at a platform level. So we imagine more immersive browsing experiences. So as I'm planning my vacation, I get to go on vacation, I can pick an activity, right? And really get into it. Now, while I'm watching the video, I can continue to learn more about the destination or the activity, seamlessly. Now, as good as this looks, it looks even better when you go full screen. So now,
wow,
I'm in full screen video.
So now you have a 17-inch whole laptop.
And I have a full 17-inch desktop that you can use with keyboard, mouse, like you talked with Christian about. Because you always have me on the go.
Add stylus support to that Wacom with pressure.
All the time. Folds up. It's a footprint of an ultra thin and light 13-inch system.
That's fantastic.
So we're super excited. It's so much fun to be able to partner.
Okay, now let go of it.
Like
I want to see it spring open, please.
What's next in laptops on Intel?
It just boing.
Yeah, awesome.
Thank you.
Falls on the floor.
Okay, I'm going to shift gears now because at the heart of all these wonderful platforms is a world-leading CPU. And last year I got on stage and we previewed our 10th generation Core products mobile processor called Ice Lake. And as you remember, we built industry-leading AI performance into that processor. So I've got a special treat that I wanted to do differently for you because everybody asked me about AI, machine learning on the PC. Why is it important? I've got a guest with me today. He's the principal worldwide evangelist for Adobe, Jason Levine, and he's going to show you some creative experiences that we've
democratizing creativity with Adobe and AI.
Jason, good to see you.
Good to see you too.
I secretly wish I had that hair. Anyway. So hey, I know you've got this thing ready to go to show some great experiences based on AI.
Yes.
So why don't you take it away?
All right, so even before I start, so how many of you are Photoshop users? Thousands of hands.
Wow.
We thank you. So I'm going to showcase today some very super cool AI
Okay.
powered by Adobe Sensei, driven by the power of the 10th generation Intel on this amazing thin and light device, which really solves a lot of the issues that Photoshop users and designers face every day. And the first is quite simply making selections, right? So here we have an image that I shot in Africa, and of course we want to select this. Now, depending upon all the various tools that you have, it can take some time, even with a stylus, because we have fur or hair. Anything that isn't just a sharp, hard edge is time-consuming, right? But
You could
again,
do this now with
Intel
just,
Adobe
what is it,
powered by
select
Sensei.
subject.
We can now simply come up to our select menu here. I'm going to choose select subject.
Yeah.
And in seconds, something that could have taken minutes is now done. And we have a perfect selection.
But that's not
every
even-
strand of
Wow.
hair, every piece of fur. The
That's not
fur
new.
Preserved. Your minimal excitement says it all.
Yeah, you're good, dude.
Thank you, sir. I'm still excited.
I like GB's comments. Good stuff.
But why do we make selections anyway, GB?
I don't know. Why do we make
Why do we
suggestions,
make
Jason?
selections? Well, because we want to cut things out, right? We want to remove the background. We want to composite something into something else. So again, that's a multi-step process. And here we have an image of a flower with a bit of a soft edge. We've got some light leaks. We have some bokeh. So again, not fur, not hair, but a bit more challenging in terms of getting a refined edge, exactly, separated and isolated from the background. Well, leveraging AI, we now have the ability to not only make this a two-step process, but make it a one-step process.
Yeah, I saw that in
With
the
a
side.
single click, which you'll find inside of your properties panel called Remove Background.
Yep.
I'm simply going to click on Remove Background, and just like that, it does that. I'm going to come up to my Edit menu here. Let's go into Transform Scale, where I will simply scale down our little rows here, and you can see I've got some other branches growing inside of a cup right here. Yes. Thank you. Oh, don't hold back.
That's fantastic.
No.
No, and I said, you know, this is basically you guys leveraged OpenVINO,
Yes.
and the CPU acceleration to go drive this with Adobe Sensei, which is amazing.
Absolutely.
And somebody like I could maybe do this. Maybe.
You can absolutely do this.
And
And
I know you also have a video example you wanted to show us that is using acceleration on the GPU with WinML.
Yes, and again, you know, this isn't only about speeding up creativity, but it's really allowing AI to be your creative concierge. I just came up with that. I'm not even quite sure what that means.
That's pretty good.
I like it.
It's assisting you. It's taking your bags and getting you there. And it's going to do things for you faster and more efficiently so that you can deliver your content to your customers, to your viewers, to your followers, to anyone, anywhere. So here we have some video that was shot, some beautiful 4K, and I want to emphasize again, 4K playing in real time, full frame on this thin and light machine, powered by Intel and Adobe Sensei. And in this case, we want to deliver this maybe to one of our favorite social networks. But social networks have lots of different aspect ratios. You have square, you have 5x4, and you have vertical, very popular and commonplace now, found in services like Snapchat or Instagram Stories or TikTok. Well, the issue is if we just exported this in a vertical frame from this widescreen frame, you're seeing that our skier is moving in and out of the center of the frame. So as an editor now, what that means is I have to go in here and I have to
And you have to
manually
pan it.
crop and
Yeah.
reframe that video before I can export. And that's at a time loss to me. So, with Adobe Sensei now, powered by Intel, I can simply right-click on Auto Reframe. I can choose Auto Reframe Sequence, where now I have an option to choose a whole series of different aspect ratios. In this case, we're going to go to the standard vertical 9:16. I'm not even going to modify anything else. We're going to go with the defaults. And something that would have taken time, lots of time, done. Just like that. And it's not just analyzing the motion. It's not just analyzing faces. It's looking at region of interest. It knows what all of your people, all of your viewers, all of your followers, all of your customers want to see. Can you feel it?
All right.
Okay.
I feel my hair growing.
Stop.
Calm down.
Now you're just rubbing it in. All right, with that, thanks, Jason. I appreciate it. Thanks, man.
Thank you.
Appreciate it. Give him a hand. I love
Someone's
it.
got to do something about that guy.
Oh my goodness, how do you follow that up? Well, hey, last year I told you that we would have 10th generation Core Ice Lake systems with AI in time for holiday. We kept that promise. And this year I'm happy to be back, and I'll make you another promise. I wanted to now introduce you to, for the first time anywhere, a great look at what will be our next and our newest Intel Core-based processors, codenamed Tiger Lake. Could you roll a video, please?
Tiger Lake.
Welcome to a magical place A place where the diverse engines of modern-day computing work side by side in perfect harmony. A place where CPU improvements drive double-digit performance gains. New advances of AI enhance real-world experiences for mobile PC users worldwide. And the unprecedented quality of Intel's new Xe architecture expands what's possible in the world of thin and light. All made even better by the blazing speeds of Thunderbolt 4 and Gigabit Plus. Welcome to Tiger Lake. Coming soon to a thin and light near you.
All right.
I like that. Was good presentation.
Well, ladies and gentlemen, I'm pleased today to show you our new SoC, our newest next-gen core mobile processor, codenamed Tiger Lake. I have that with me. In fact, Tiger Lake is powered on. It's working. It was, in fact, running the Horseshoe Bend demo that Chris Walker came out, the large screen foldable. It's running Tiger Lake. And with me in my hand, I also have our smallest U-Series motherboard for Tiger Lake that we developed in parallel, smallest U-Series motherboard we've ever done to drive industry-leading innovation and performance. So here they are. Okay. All right, now, Tiger Lake, we know, is going to really redefine the mobile computing experience yet again, and I've got a guest who's really excited to talk about it. So please join me in welcoming on stage our Vice President of Intel Architecture, Graphics, and Software, Lisa Pierce. Lisa, come on out.
Cool.
Hey.
Hey, thanks for having me.
Yeah, you're welcome. So hey, you know, Tiger Lake is a really special platform. Some of that is because of huge performance gains on the CPU, and some of it's about graphics. Why don't you tell folks about it a little bit?
Absolutely. So Tiger Lake is one of the first products with our new Xe graphics architecture. It is our most disruptive and advanced architecture yet. And so we're super excited. It brings
This is
gains
big.
in efficiency, also doubles the graphics performance versus the previous generation.
Right.
What does that mean? HD performance gaming for hundreds of millions of notebook users.
That's right, right, with integrated graphics, which is awesome.
Yeah.
So yeah, oh, you got to get excited about that. So instead of just talking about it, you want to put it through the paces.
Yeah, let's do an
and show it a
example.
little bit?
So the system here is Tiger Lake running an ultra thin and light system from Quanta. It's running the game Warframe, and you can see it looks pretty good.
It looks fantastic, and it's running real time right there with integrated graphics in that incredibly thin and light form factor Tiger Lake from Quanta.
Yep.
But it's not just about the performance you guys drove for gaming, which is amazing. It's also about media and AI and other things, right?
Absolutely. So gaming is just the start. We also have advancements in media and display capabilities, as well as AI improvements built in. And that really brings productivity use cases to light. And so an example of that, lots of people have low resolution photos or blurry photos. And you can imagine if you can instantly correct those. And so Topaz Labs enabled an application we'll show you here. And
Gigapixel.
So in the top right corner, this is the original photo. And then we've zoomed in because we really want to take a look at this eagle. And so
you've got a big photo. You've zoomed way in on the eagle, which now looks fuzzy because you zoomed all the way in. Right.
Looks pretty fuzzy.
Yeah.
And so if I go and select this here, it's going to use the OpenVINO framework to go and drive this improvement on Tiger Lake.
13,
so
25,
take a
50.
look
Nice.
at it after, and you can see the difference between these two. Right?
Pretty good.
So it's awesome.
That's all done using AI acceleration on the GPU, which is great.
Absolutely.
No, that's fantastic. So just to recap for everyone, for me and you, since we're near the end, double-digit industry-leading performance, extending our leadership in mobile even further in high performance by double digits, and we're not talking 10%. We're doubling the graphics performance generation on generation, industry-leading AI.
And Lisa Pierce, she won't bullshit. She's been doing this graphic stuff for Intel since like the first flop
thanks for joining me on
dedicated graphics card that they made.
Wait, you had one more surprise.
When I went to the thing at GDC.
So,
oh, let me
one
see
more
this.
I'm thrilled. I didn't forget. I'm thrilled to share with you today our very first discrete graphics processor up and running. It's called DG1.
Fuck.
So we'll give you a demo of DG1.
Yeah.
So this is DG1 here.
Now, I know
It's been up here the whole time.
We're taking some risk. It's early days. You've got DG1
Very
up here
early.
running on stage.
Correct. This is in a mobile form factor. It's running Destiny 2. And you can see, even though it's early, we're extremely excited about the gaming experience that we'll see on DG1.
That's right.
How is it running on the laptop?
You know, for those more power mobile users.
Explain. Is it behind it?
Activities. It's going to be fantastic.
Absolutely.
As well.
Don't do this to me.
Thank you for staying on and also
Well,
showing
thanks.
us DG1
We're super excited.
working. Thank
A lot
you
more
so
to come
much.
this year.
All right, everybody, give her a
Thank you
hand.
so
I
much.
appreciate it.
But yeah, like I was saying,
Okay,
when I went to
and
GDC,
with that,
she told some stories
wanna,
about back
thank you all
then.
for
She's
coming
real
on
passionate
behalf
about graphics. She
Bob,
won't bullshit.
Dean, and myself.
So
Thank
I
you so
believe
much.
this
You can
shit.
count
I
on
believe
Intel
it.
to continue
I feel
building the
that.
positive benefits of compute-enabled intelligence that we think will enrich the lives of every person on the planet, and that's the whole purpose behind our mission at Intel. Thank you all very much. Have a fantastic CES. Thank you.
Let me turn back on my controller, pause this shit. Come on, hand. So, that was AMD getting fucked right there, to be frank. And, yeah, AMD's didn't announce anything. They didn't show off anything innovative. They were just like, here's the product that we were saying that we were going to launch anyway. Here's some mobile stuff that's boring. This was some real shit. I don't know. Hopefully this, when I'm done editing this video, this comes out interestingly. And I'll see everybody later.